Alright, welcome to part 3 and hopefully the final part of this one. Now, hopefully you at least tried to set this one up. Now, it's like the other two in that we're told it triples every 3 years. So the base of our power is going to be 3. And it gives us our starting population. We start with 26 and it's going to grow to 170,586. So we can use that to start to set up our equation here. Okay, so putting in our values here, we'll have 170,586. Okay, we're going to start off with 26. Our base is 3. Now, with our x here, we're trying to find the amount of times, how many years it takes. So if we're looking at 3, we're tripling our population, but again, it triples every 3 years. So the number of years we have that we're looking for is actually going to be divided by 3 inside that exponent. So you have t divided by 3. Okay, and we're actually trying to solve for t in here. So this was the first one that we've seen so far today anyways, that we've had to solve for the exponent. So what we need to try and do here first is isolate the power here. Because remember, with an exponential equation, our goal is to get both sides of the equation under a single power with the same base, and then try to equate the exponents. So what I'm going to try and do here, I'm going to divide both sides of the equation by 26. Just try and get that power by itself. When I divide 170,586 by 26, I get 6,561. Okay, now the only way we're going to be able to solve this is if the left side of this equation, 6,561, is a power of 3. Hopefully it is. We can play around with it for a little bit. And again, if you at least trying to get it to work as a power of 3, try different exponents in your calculator, because you may not recognize this immediately as what exponent it would be that you'd put on 3, but if you play around through your calculator, you'll eventually see that this is 3 to the exponent 8 to be 6,561. Okay, so once we get into this situation, now we can start equating the exponents. So 8 will be equal to t over 3. So that'll give us a final value for t of 24 years. Okay. So this one we had to solve for the exponent, but again, we've solved exponential equations before, so hopefully this wasn't too bad. Okay, a few more examples here. So if you've ever done chemistry before, you may have heard of the term of half-life. So essentially, with any kind of a radioactive substance, it has a half-life, and that means it's the amount of time in which the substance naturally decays to half of its original amount. Okay, so essentially, if we're saying that this random radioactive substance has a half-life of 45 days, if we start off with 1,000 milligrams, after 45 days, naturally it will decay. You're only going to have 500 milligrams left. Okay, 45 days after that, it will decay to half of that value, so it'll go from 500 to 250 in the next half-life, the next 45 days. And then from there, it'll half again every 45 days. So it'll go from 1,000 down to 500 to 250 to 125, and so on and so forth. Okay, so that's what half-life is. So if it's halving every 45 days, we're going to have the base of our power be 0.5. Okay. We're starting with 1,000 milligrams. That will be our C. We want to know how much is left, so that's going to be our Y. But it's going to be after 74 days. So again, we can't put in 74 as our exponent, because that would say, again, if we look at this equation here, if we put in 0.5 to the exponent of 74, we're saying it's halving 74 times. Okay, it's not having 74 times, it's having every 45 days. So in 74 days, is going to have 74 divided by 45 times. So the number of times it halves in that time period will be 74 divided by 45. So that gives us our x value. Okay, so very similar to the populations that was tripling, right? Tripled every 3 years, we divided our number of years by 3. Here it's halving every 45 days, we divide our number of days by 45. Okay, so we're trying to solve for y. We can run all this through our calculator. 1,000 times 0.5 to the exponent of 74 over 45. Okay, and when you run that through your calculator, you should get about 319.9 milligrams. Okay, so with that in mind, I would like you to try B. It's another half-life problem. Same half-life, actually, 45 days. So try and set up this equation, solve for whatever unknown it wants here, and we'll take it up when you're ready. Okay, so first things first, if you want to check your answer, you should get 225 days for your time to look at how we got that. So we're going to start with 1,000 milligrams, so that's going to be our C value. We're going to end with 31.25 milligrams, so that's going to be our y. Its half-life, so we're going to start with a base of our power of 0.5 for our a. And we're looking for the amount of time, so we're looking for the amount of time until we have that final amount of 31.25 milligrams. Now, again, for our exponent here, because it's a half-life of 45 days, we need to divide that by our half-life period, which is 45. So our exponent is going to be t divided by 45. So our exponents in the, our unknowns in the exponent. So we're trying to get, again, both sides of the equation under the same, under single power with the same base. So first thing I'm going to do here, and I have my equation set up, is divide both sides of the equation by 1,000. So I get 0.03125 and on the left, and 0.5 the exponent of t over 45 on the right. Now, you may not immediately recognize this as a power of 0.5, and that's very fair. Now, if you want to, you could leave it as fractions, and then you could write 0.5 as 1 over 2, and then try and make the bases work that way. But the only way you'll be able to solve this, at least in grade 11, is if both sides of the equation can be written as a power of the same base. So let's try and express the left side as a power of 0.5. If you try a little bit of trial and error in your calculator, will tell you, without not too much work, that 0.5 the exponent 5 is 0.03125. So we replace that, and now we can equate the exponents. 5 is equal to t over 45, and then when you solve, you get 225 days for t. Okay, so again, we're just going to do a couple more quick examples. Well, not necessarily quick, but a couple more types of problems that you might see, and then we'll call it a day. I'll give you a chance to practice. So here we're told the number of bacteria goes from 500 to from 50 to 1600 in 1 hour. We want to find how long it takes to double. Okay, so first off, if we're dealing with doubling period, we're going to have a base of the power of 2. We start with 50, that's C. We end at 1600, and that is Y. Okay, now I didn't specify the units I would use for the length. Now, if it goes to from 50 to 1600 in 1 hour, the time to double, so to go from 50 to 100, will be a lot less than an hour. So I'm going to put the length of doubling period in minutes, just so I'm not dealing with fractions or decimals or pieces of an hour. So for the doubling period, if it takes 1 hour, that's 60 minutes, but I need to divide that 60 minutes by the amount of time it takes to double. So if I let d be that doubling period, my exponent will be 60 divided by d. Okay, so if I set up this equation, again, putting in everything that I know, okay, in theory, I should be able to solve for d. Okay, so let's work through the algebra here. So divide 1600 by 50. So you should get 32. So 32 would be 2 to the exponent of 60 over d. Okay, now by now you should be able to recognize 32 as being 2 to the exponent 5. Okay, so now you can equate the exponents. So 5 is going to be equal to 60 over d. Okay, so that would mean 5d equals 60, and d would then be equal to 12. Okay, so it should in theory take now 12 minutes for it to double. Alright, so one last example. Again, why don't you try this one on your own? Try and put everything together. So I'm giving you the half-life. I'm telling you how much it weighs after a certain amount of time, and I want to figure out how much it weighed initially. So I'll let you try and work through that on your own, and then we'll run through it together. Okay, so I'm starting with y equals c times a to the x. So I'm told that after 16 days the sample weighs 0.75 grams. That's our final amount, that's y. We don't know what we're starting with, that's what we're looking for, that's our c. We're dealing half-life, so our base is going to be 0.5. And for our exponent, we're given 16 days, but the half-life is 4 days. We can't put 16 as the exponent, because it's not having 16 times in 16 days, it has actually every 4 days. So we take the 16 days, divide it by 4, and it gives us an overall answer of 4, overall exponent of 4. So we wind up with 0.75 equals c times 0.5 to the exponent 4. Divide both sides of the equation by 0.5 to the exponent 4, and you can wind up solving for c and getting 12. Alright, So that's it. That's a lot of word problems that we've gone through the last couple of days. So you can continue on with the homework. A couple more examples from the textbook worth trying, and then I gave you guys a worksheet with a bunch of other interesting types of problems on there. They're definitely worth trying if you're getting ready for the test. Okay, so that's it for the exponential functions unit. Again, once we finish this one, we're going to move on and start trigonometry.